Today we're looking at equations of tangent lines using the derivative. Okay, so let's take a look at this function here. We have for the function f of x equals 2x squared minus 3x, determine the derivative at 4. So let's get the derivative first. The derivative is 4x minus 3, so then f prime of 4 equals 4 times 4 minus 3, which equals 13. Second one is just without the apostrophe, so that's just regular 4 substitute into the regular function. So we'll have, this is 32 minus 12, that equals 20. Hence, find the equation of the tangent at, I guess they mean at the point x equals 4. So, over here at x equals 4, we have a slope equals the derivative, so the slope is 13. But that point is 420. That's what we just worked out here, right? That point, we plug in 4, we get 20, so that point is 420. So the equation is just y minus 20 equals slope times x minus the x value at that point. Okay, and then in part D, determine the equation of the tangent to the minimum point of the curve. Okay, so we can set the derivative equal to 0. Let's try it that way. There's two ways to do this. It didn't say hence here, so I don't have to use the derivative. Now if you solve that, you get x equals 4/3. And then we can get the y value by substituting in 2/3 into the equation. Okay? So like f of 4/3 equals 2 times 4/3 squared minus 3 times 4/3. Okay, but we can just graph it. Let's graph that original function. Let's go to our HP prime, go to apps. I'm going to save that one for later. I'm going to turn on the second one. I got typed in first. 2x squared minus 3x. Okay, and plot. Okay, I'll need to zoom in a lot. Shift plot. I'm going to change this x range to like 10 or something. Okay, well now I can see it a lot better. So it is indeed a parabola, but where the minimum point is, we can just go to menu, function, extremum. So that gives you 0.75, which we saw already. Actually, I think I made a mistake. That's 3/4. Well, thank goodness I used a calculator to double check. This is actually 3/4. I went the wrong way around. So we substitute in 3/4. Anyway, the calculator gives it for us. It's just negative 0. Let's draw a sketch. Yeah, 0.75, negative 1.125. So the equation of the tangent here is just a horizontal line. So it's going to be y equals whatever the y value is at that point. So it's negative 1.125 is the equation of that line. Okay, next, let's take a look at this question here. A hill can be modeled with this function. Sketch the graph. So this is a negative. I know it's going to be a downward facing parabola with a y-intercept of 0. So I kind of already know what it looks like. Okay. I won't go beyond that because this is modeling the side of a hill. So let's just keep it at ground level there. Alright, let's go to apps, function. I will graph it now. Okay, we'll need to, you can probably zoom on it with your handheld device, but I'm going to go shift plot, and change the x maximum to something like 300. See if I can see it, and I can see the whole parabola, right? So the important points here are maybe the x-intercepts. Let's go to root, and we get 170, and this is 170, and this is 0. My scale, I think I went up to 200 and 300, so I can label that as well. find the derivative of the function. So the derivative is equal to 2 times that is negative 0.04x plus 3.4. Number C, find the gradient of the tangent where x equals 50, so you can just substitute in 50. And this gives you a negative 2 plus 3.4 is 2. Okay, we can easily check that on the graph. We can go to 50, click enter, and then function slope. So the slope is indeed 1.4 when x is 50, so the derivative should be, 1.4. I made a mistake, 1.4, because it's 2 plus, negative 2 plus 3.4 is 1.4. Hence, find the equation of the tangent line at that point. Okay, well, let's look at our graph. We're talking about the point up here. The slope is 1.4. We know the coordinates because we put in x equals 50. Do we have the y value? No. So we can go to, well, you can substitute it in to find the y value, or you can actually just go to the table. So at x equals 50, you can type in 50 and press enter, and it'll take you here. It's 120. Okay, so that's 120, and the equation of the tangent is then going to be y minus 120 equals slope times x minus 50.